Okay, this is problem 1 from the Unit 1 review. And if you look up here, you'll notice the first thing I did is I graphed this function in my calculator, y equals. And here's what your graph should look like. So whatever is on your paper better match that. And then I used a table here to get some nice clean points. So you'll notice my lowest point there is -6, -2, -5, -1. I plotted these points, and I connect them with a nice smooth curve. And it looks just like a square root function should look, but shifted to the left 6 and down 2, okay, which you should know from your transformations. Now, I'm going to look at the table, the graph, and I'm going to think mathematically in order to do the domain and range. So to start, domain. Domain is all the x values that are allowed to be plugged in the math. And remember, the rule is I cannot have negatives under the radical sign. Okay, and that's why -7 gives me an error, -8 gives me an error. So you'll notice the values that it likes for x are -6 and in the positive direction, going towards positive numbers. So the way I would write that is close bracket, -6, comma, and it's going to go forever to the right. And you can also see that in my graph right here. My x value is -6, and it goes to the right forever in that direction. Okay, range. Range is a little bit more difficult to see at times. Okay, that's kind of my up and downness. And again, though, you'll notice the lowest value I will have for my range is -2. And again, the numbers are getting bigger, and you can kind of see that as well right here in my graph. Okay, this right here, -2, and then it goes up. Even though it's gradual, it does go up forever and ever and ever, and I can see that on a table and keep scrolling. So my range is close bracket, -2 to positive infinity. All right, continuity. Is this continuous? If I flow my finger around it, does it ever have to come off the paper? And the answer is no, it does not have to come off the paper. Therefore, it is a continuous function. Continuous. Increasing or decreasing, if I go left to right, you'll notice as I trace it, it is always going uphill. So it's increasing. And it's increasing the entire function. So I'm just going to recopy my domain here. Odd, even, or neither. Okay? That is if I were to rotate it 180 degrees, would it line up over the origin? And that is a no, so it's not odd. If I fold it in half over the y-axis, would it line up? And that is also a no. So this is a neither scenario. Boundedness. Is there a boundary line that the math will never cross? And if I make a line down here below, you'll notice if that were like a boundary, the math is never going to go below it. Okay? So the boundedness is below. Extrema. There is a local extrema. There is a min at this point right here. So I would say min at the coordinate -6, -2. And now, last but not least, asymptotes. Okay? Now, a lot of people will just draw lines here and say, yeah, that's a vertical asymptote, but that's not what I'm looking for. Okay? I'm looking for the math to brush up against that line, and that is not happening in this scenario. Okay? And the only time I have a vertical asymptote is if I'm dividing by 0. And if you look at the math up here, there is no division, so I'm not worried about dividing by 0. So my vertical asymptote is none. Okay? Same with my horizontal asymptote. Again, I don't see anywhere where it's brushing up. And people might think maybe here, because it kind of looks like it's approaching a number, but if you were to scroll down your table long enough, you would see it just keeps going up and up and up. So that is not my vertical asymptote right there. Okay? Get rid of that. And also we have that table where I'll often say, is it same, bottom bigger, or top bigger? Well, if I look at this function, it's not even a fraction. So if I put it over 1, okay, now it's obviously top bigger. And so my answer here is also none.